Advanced Algebra 2, Concept 10, Solve Quadratics by Factoring. This is Level 2 Factoring. So I've got this on the graphic earlier from your notes, just so you can look at the process to factor a polynomial. We are going to use the same process that we have been using. We're going to look at, first of all, step 1, if we have a greatest common factor. Then step 2, at how many terms we have. If we have 2 terms, we're going to look for a difference of squares pattern and see if we can factor it using that difference of squares pattern. If there are 3 terms, now we're going to look for trinomial factoring, level 1, and then I'm going to teach you how to factor level 2. Level 2 is when our a value is not 0. Is not 1. We're going to continue then, step 3, if you need to solve, we set each of our factors equal to 0 using the zero product property and then solve. All right, so get to this graphic, and this is level 2 quadratic factoring, x squared plus bx plus c equals 0, but this is when your a value is not 1, and so we're going to use, just have to do a couple extra steps to account for that a value. This method is called factoring by grouping. So we're still going to do the same thing that we did before with level 1. We're going to identify our a, b, and c, and we're going to find 2 numbers whose product is a times c, and sum is our b value. So in this case, a is 5, b is negative 17, and c is 6. So a times c, 5 times 6 is 30, and our b value is negative 17. So 2 numbers that will multiply to give us 30 and combine to give us 17. Well, hopefully 15 and 2 jump out at you. And if we make them both negative, then our signs will work out. So now look at number 2 over in the left-hand column. It says we're going to rewrite the middle term using the 2 factors that we found in step 1. So we're going to bring down our first term, our 5x squared. We're going to rewrite negative 17x as negative 15x minus 2x plus 6. Then what we're going to do is step number 3. We're going to group the first 2 terms together and the last 2 terms together. Now I'm going to do that by drawing a simple small dividing line right after my second term. I don't extend it down, I just do it right in that line of the equation. Now I'm going to factor out a greatest common factor from each pair. So I look at the first 2, 5x squared minus 15x. I can factor out a 5 and an x from that. And then I open a parentheses and write what I have left. So when I divide out 5x, I'm left with an x in the first term and then minus a 3 in the second term. Now I look at my last 2 terms, negative 2x plus 6. I can factor out a negative 2. And if my first term that I'm looking at here, it's the third term in our quadratic, is negative, I'm going to factor out a negative. So I factor out a negative 2. I open my parentheses, and what I have left is an x, and then 6 divided by negative 2 is negative 3. Then we factor out our greatest common factor expression. Notice that the x minus 3 is common. So we're going to factor that out to the front. And then when I divide out x minus 3 from each of these terms, I write what I have left, 5x minus 2. Now, if you look at those and in your mind multiply them back together, you'll see that you will get the original quadratic, that we have factored these correctly. So let's go ahead and do this check step. We're going to multiply x minus 3 times 5x minus 2. First terms together, 5x squared. Outer terms is negative 2x. Inner is negative 15x. Last terms is positive 6. And then if we rewrite that, we get 5x squared minus 17x plus 6. So it's the middle term of once you find those 2 values, or the middle steps, you have to rewrite the middle term, and then we group the first 2 terms together and the last 2 terms together, factor out greatest common factors, and then we can get our factors. Now let's try some, okay? Remember our process. So we're going to first of all replace our f of x with 0, And then we're going to factor out a greatest common factor if we can. And that first term, it's just an x. We have x times x minus 8. We can't break those down any further. So we are done with the factoring. Now to solve, we just set each of those equal to 0. So x equals 0, x minus 8 equals 0, so x will equal 8. Number 8, let's do the same thing. Let's replace the f of x with 0 because we're solving. Now we're going to do two numbers that multiply to give us a times c. So 4 times 49 is 196, and then our b value is 28. So if I think of multiplies, pairs that can multiply to give us 196, it's a little overwhelming. But 14 times 14 is 196. So always look to see if the number is a perfect square, because sometimes those will be your factors. Because if we add them, we get 28. Now we're going to rewrite the middle term, 28x, using the 14 and the 14. So this is the factor by grouping that we just talked about. Then you're going to divide and group your first two terms together and your last two terms together, just by using that simple dividing line. Look at your first two terms, see that you can factor out a 2x. And then we'll have 2x plus 7 left. Now with the other two terms, we can factor out a 7, and we will have 2x plus 7 left. That is our common expression that now we factor to the front, 2x plus 7. Once we divide that out, we're left with another 2x plus 7. Then we can set just one of those equal to 0 because they're identical. So our solution is negative 7/2, or negative 3.5. If we graphed it, that parabola would open up and just have its vertex at the point negative 3.5, negative 7/2, 0. Let's try another. So number 9, let's replace f of x with 0. And let's identify our a, b, and c values. So a is 4, b is negative 13, and c is 3. A times c is 12. Our b value is negative 13. So two numbers that if you multiply, you get a positive 12. But if you combine, you get a negative 13. Sometimes the factors are just 1 and the number. And if we make them both negative, then our signs will work out. Notice this is a level 2 factoring because our a value is 4. It is not 1. So we need to do the factor by grouping steps. So bring down your 4x squared. Rewrite negative 13 as negative 1x minus 12x plus 3. Then draw your short dividing line to group the first two and the last two terms together. We can factor out an x in our first set of terms, so we get 4x minus 1, and then our negative 3 in our last two terms. Now look for that common expression, 4x minus 1, and that gets factored to the front. What we have left is x minus 3. And that, remember, we are solving, so we set those equal to 0. 4x minus 1 equals 0, and x minus 3 equals 0. So we can add the 1 and divide by 4, x equals 1/4, and x equals 3. Now go to the place where you're doing some extra practice, and let's try these. So write down number 1, 2x squared minus 8x plus 8. Remember that factoring process, so always look for a greatest common factor. Do you see the 2? So let's factor the 2 out. Then look what we have left. So 3 terms, x squared minus 4x plus 4. So we're looking for two numbers that will multiply. This is level 1. Multiply to give us a times c, which is 4, and combine to give us negative 4. So we've got 1, 4, 2, and 2. Look good. Let's make them both negative. So we can rewrite our quadratic as x minus 2 times x minus 2. Notice I bring down my greatest common factor of 2. Now to solve, that 2 in front will divide away, and I can just set one of my expressions equal to 0 and solve. So x simply equals 2. Now on number 2, we are at a level 1 factoring problem, x squared minus 1 minus 20. Our a value is 1, b is negative 1, and c is negative 20. So we're looking for two numbers that'll multiply to give us negative 20 and combine to give us negative 1. Again, I often don't think about the negatives at first. Multiply to give me 20, add or subtract to give me 1. So I know 5 and 4, some combination of that. If we make the 5 negative, then our signs will work out. It's level 1 factoring, so we get to go right to our parentheses, x plus 4 times x minus 5. And we're solving, so we have the equals 0. We set them both equal to 0 and solve, so x will equal negative 4 and x will equal 5. Now on number 3, notice that we have two terms. So remember, let's look for a difference of squares. It definitely is a difference. 9 is a perfect square, and so is x squared, and 4. So I realize that 9x squared is 3x that's being squared, and 4 we can think of as 2 that is being squared. So we have a difference of squares. So that will simply factor as our first term plus our second term, so 3x plus 2 times 3x minus 2. Then if we set those both equal to 0 and solve, so we'll get x equals negative 2/3 and x equals positive 2/3. All right, number 4. So let's pick out A, B, and C. No, let's take out a greatest common factor, of 3. I bet you saw that. Now let's pick out A, B, and C. So A is 3, B is 5, and C is negative 12. So I need two numbers that multiply to give me 3 times negative 12, which is negative 36, and will combine to give me 5. Hopefully the pair of 9 and 4 jump out at you. If we make the 4 negative, then our signs work out. Now we're just going to focus on that quadratic for a moment. So bring down your 3x squared. You're going to rewrite using your 9 and negative 4. And then you're going to divide because we're going to factor by grouping. So the greatest common factor in our first two terms is 3x and then a negative 4. Now look for the common expression, which is x plus 3. That comes to the front, and what we have left is 3x minus 4. Bring down that greatest common factor and your equals 0. And now we're ready to resume solving the equation. So let's divide by 3 and then set those each equal to 0. So x will equal negative 3 and x will equal positive 4/3. All right, that concludes the first part of the Concept 10 notes at level 2 factoring. In part 2, we're going to do a few more examples of factoring with some level 1 and level 2, and then we're going to look at some real-life quadratic problems.